Hi, in this lecture, we need to learn about the basics of binary and hexadecimal number system. The computer uses binary system 0 and 1s. In order to process them, each 0 or 1 is called bit, and each 8 bits are called byte. For example, starting from left to right, 0, 1, 0, 0, 1, 1, 1, 1 are 8 bits. And because there are 8 bits, then we can call it byte. The first bit is laid on the right side, which is called least significant bit. And at the left side, we call it most significant bit. Now, this binary system can represent numbers. Let's lay out bit positions from bit 0 to bit 7. So we have 1 byte, which are 8 bits. Because we use only 2 things, which are bit 0, the 0, we are using 0 and 1, so we call it binary. And because we use 2 things, then we use the number 2 to represent the base of an exponent, and this exponent represents the bit position. Each bit is multiplied by the base 2 to the power of the position of the bit. So the least significant bit, which is bit 0, has a base 2 to the power of 0. And any number raised to the power of 0 equals 1. Now, bit 1 has a base 2 to the power of 1, which equals 2. The exponent 1 means the number 2 exists only one time, so the result is 2. Bit 2 has base 2 to the power of 2, which equals 4. Because the exponent is 2, and it means 2 multiplied by 2, which equals 4. And for the bit 3, has base 2 to the power of 3, which equals 8. Because the exponent is 3, and it means 2 multiplied by 2 multiplied by 2, which equals 8. And so far and so forth. Each bit position, which can be 0 or 1, will be multiplied by the base 2 raised to the power of the position of the bit. For example, if we want to represent the number 3 in the binary system, then we need to set the bit 0 and 1 to 1 and leave the others set to 0. Because this will give us 1 in the bit 0 plus 2 for the bit 1, and by adding all, it will give us 3. Let's take other examples. The number 11 can be represented by 0, 0, 0, 0, 1, 0, 1, 1. And also, let's take another example. You can see now we are using the bit position, the bit 0 and the bit 1 from right to left, and the bit 3, index 3. Okay, so we have 0, 1, 2, and the 3. So we have 0, 1, and 3. We are using them. We set them to 1. So it will give us 8 plus 2 plus 1. We will have the result will be 11. Okay, let's continue. Another example, the number 132 can be represented by 1, 0, 0, 0, 0. 100. You can observe that we are using the bit position, the 2, okay, because we are starting from 0, from right to left. So we have like 0, 1, 2. So the second, it will be the third one, okay. So but because the base index is 0, so it will be bit 2 and the bit 7. We are using them, the bit 2 and the bit 7, okay. We set them to 1. So we will have 128 plus 4. So we will, the result will be 132. What you need to remember is the numbers from right to left: 1, 2, 4, 8, 16, 32, 64, 128. And for example, if we want to represent the number 6, then we set the 2 and 4, the numbers that we have in front of us, okay, to 1. Okay. Another example. The number 13 is represented by 00001101. As you can see, we set to ones the number 1, 4, and 8, because if we add them, then we can get 13. Another example. The number 97 is represented by 011000001. Now let's talk about hexadecimal system. Hexadecimal system starts from 0 to 9. Then instead of 10, it continues with the letter A, and instead of 11, we use B, 12 for C, 13 for D, 14 for E, and 15 for F. So the hexadecimal number has the range from 0 to 15, which has a total of 16 numbers. Each 2 decimal digits considered as a byte. Let's take an example. The number 18 can be represented as 12 because this is a 16 base system. So the base will be 16 to the power of the position of the number. It's much like the binary system, but with the base of 16. Okay, so we will have here 16 plus 2 will equal 18. Okay. Let's take an example. The number 36 is represented by the hexadecimal 24. Because 4 plus inside the parentheses 16 multiplied by 2, the total is 36. Good. Now, let's talk about converting the hexadecimal number to binary. Each hexadecimal number represents 4 binary bits. So, if we convert the hexadecimal number 12, we get for the digit 2, 0010, and for the digit number 10001. Then we combine them together to get 0001 0010 from left to right, which is the number 18 that is represented in the binary system. Let's take another example. The number 28, we convert the 8 into binary 4 bits, which will give us from it will be 1 0 0 0. Okay, and for the number 2, it will be converted to 0 0 1 0. And when we combine both, they will give us 0 0 1 0 from left to right. 0 0 1 0 1 0 0 0. Thank you for watching the lecture.